Hi, section 4.2 coming at you. Okay, we're going to start with problem 1 on the homework. I'm just going to go through this problem and, do it with you, explain why we get the answers we get. The question is, which of the following represent functions of x? And a function is a formula that gives you exactly one answer for y when we plug in an x value. So we look at these 3 different formulas here, and when we plug in an x value in part A, do we get just one answer for y? Like if x is 4, we get 2 times 4 plus 1 is 9. We don't get another answer, just one answer. So part A, y equal 2x plus 1, this is yes. It is a function of x. Okay, part B, y equals plus or minus square root of x. Okay, now if we plug in an x value, we get 2 different y values. So that means it's not a function. Because if x is 4, for example, y is square root of 4 and y is negative square root of 4. 2 answers. So that makes it not a function. A function gives you one answer for the input value. Now part C is a little trickier. In part C, if x is 2, y is the absolute value of y equals 2. Now the absolute value of 2 equals 2, but also the absolute value of negative 2 equals 2. So y is 2 or y is negative 2. 2 values of y for each x, so that is also a no. And in the homework, I gave you some solution points, and they pretty much show you the same thing as I showed you here with these points that I chose. Okay, the second question in the homework for 4.2 says y equal absolute value of x plus 1. Describe a function of x. Okay, if we plug in an x value, do we just get one answer for y? Like if x is 10, y is absolute value of 10 plus 1, which is 11. One answer. If x is negative 2, y is absolute value equal to absolute value of negative 2 plus 1, which is 2 plus 1, which is 3. One answer. So the answer here is yes, every x we put in gives us just one y value. So it is a function of x. Okay, let's try a problem like number 3. If f of x equals 3x minus 1, find f of 2 and f of negative 2. Now when it says find f of 2, that means replace each x in the formula with 2. So f of 2 is 3 times 2 minus 1, which is 5. So our answer here is 5 for f of 2. And then for f of negative 2, we plug in negative 2 for each x in the formula. So that's 3 times negative 2 minus 1, which is negative 6 minus 1, or negative 7. So just remember, replace each x in the formula with whatever comes after f in those parentheses. Okay, and here's one for you to try. If f of x is 1/2 x plus 1/5, evaluate f of 3. Pause the video and try this on your own. Remember, if you don't try these on your own and just watch me, you won't learn it. So, to evaluate this, we take that 3 and plug it in for the x in our formula. Whatever's in parentheses after f, you put it in for each x of the formula. So we get f of 3 is 1/2 times 3 plus 1/5. So that's 1/2 times 3 over 1 plus 1/5 is 3/2 plus 1/5. And we need common denominators of 10. Remember, if the denominators don't share any common factors, the product of the denominators is the least common denominator. And that's the case here. Least common denominator is 2 times 5. So it's 15/10 minus 2/10 makes 13/10. And I see a little mistake there. We are to add, not subtract. So it's 13/10 plus 2/10 is 17/10. Sorry about that. Now that is the correct result. Okay, let's try one like number 7. Our formula is f of x equal x squared minus x, and we are to evaluate f of h. Well, h is our input value. It's not a value, it's a variable, but we can plug it into the formula just the same. So f of h is h squared minus h. And that's all we can do with this. H squared minus h. And that's your answer. Okay, let's try one like number 6. If f of x is the formula 2x plus 1, evaluate f of x plus 3. Well, this one's kind of weird, I know. But our input value is the whole expression x plus 3. We're going to replace the x with x plus 3. So we get 2 times that x plus 3 input value, and then add it to 1. Then we can multiply out with the distributive property. 2x plus 2 times 3 is 6 plus 1, and that simplifies to 2x plus 7. Okay, now here's a problem for you to try. If f of x is 3x plus 1, evaluate f of x plus 1. So pause the video and try this on your own. Okay, like the last example, we plug the x plus 1 in for the x, and we get 3 times the quantity x plus 1 added to 1. Use the distributive property, 3 times x plus 3 times 1, and that simplifies to 3x plus 4. Okay, I'm going to look at a problem, a different version of number 8. Basically number 8 with a different temperature Fahrenheit. Number 8 gives this function degrees Celsius equals 5/9 times T minus 32, where T is the degrees Fahrenheit. So this allows us to convert from Fahrenheit to Celsius. For example, if I put in 32, which is the freezing point, in degrees Fahrenheit, I get 0 for the degrees Celsius. Okay, here I want you to find degrees Celsius if the temperature is 50 degrees Fahrenheit. And I want you to try this on your own. Okay, so our input value is 50. We're plugging it into the formula for T. C of 50. It's not C times 50, it's C of 50. The degrees Celsius as a function of 50 degrees Fahrenheit equals 5/9 times 50 minus 32. Okay, and then evaluating that, 5/9, 50 minus 32 is 18. Okay, so that's 5/9 times 18 over 1. I picked a nice value that allowed me to do this without a calculator. If it was something like 17, you'd want to use a calculator here, but 5/9 times 18 over 1, I can do that without a calculator. And we get 5 over 1 times 2 over 1 is 10 degrees Celsius. Okay, and lastly, I have a review problem here for you. Solve 4 minus 3 times the quantity x minus 1 equals 2x. So you try this on your own. Okay, and your first step here is to realize that the minus 3 here is like plus -3 times x, -3 times -1. So when we distribute, we get 4 minus 3x plus positive 3 equals 2x. And maybe if you didn't get that, maybe pause the video and go from there then and try and solve this from here. So we can combine like terms. 7 minus 3x equals 2x. And then we want all the x's on one side, so we add 3x to both sides. And we get 7 equals 5x. Divide both sides by 5. X equals 7/5. And that's all for 4.2. Post any other questions you might have on discussions.